Hi, my name is Adam Ress, and this is my Lab 2 report for Physics 2212. So here's a look at the table of contents. I'll start talking about the introduction, then I'll go into the experiment, the code discussion, and finally a conclusion. Introduction. So the goal of this lab was to more accurately calculate the amount of excess charge on a piece of Scotch tape after using physical principles to give it a positive charge. So for this lab, we used a line of charge to get a more accurate result than simply using a point charge to represent the tape. So here's a quick overview of the fundamental physical principles. So first, Newton's second law, which tells us that F net equals ma, but more specifically, we used that formula to help us find that, to conclude that the gravitational electrical forces were equal. Then Coulomb's law, which helps us find the forces on point charges, conservation of charge, and superposition principle, which tells us that independent actions can be, their effects can be added together. So here's a preview of the main results. So in this lab, we found that the charge on the tape using the line charge was 38.8 nanocoulombs compared to the previous result on the point charge lab for the tape where we only got 29.2 nanocoulombs. So this was an increase of 133%. So here's a quick overview of the experiment again. So we created these U tapes, which were positively charged because they were ripped off of other base tapes, which would pull off electrons and give the U tapes a positive charge. And then we'd have one U tape hanging, and then the other U tape, which was the same charge, would come closer. They are both positive charged, so they would repel each other, and we would record what point the hanging U tape would start to float. So we recorded that distance at to be 6.2 centimeters. So now looking at the code to model this experiment and get some values. So here's the function for the electric field. So we would calculate all the information we need in the function and then return it with basically plugging that information into the electric field formula. So that's how we would calculate the electric field. Then the function for the line charge, this would create a line charge, which is basically just a bunch of really small points that would have the total charge over n charge. So they would all have a smaller charge, but together the charge would be the same as the point charge in the previous experiment. So this function was used to create that line charge. Then in the code, we would iterate between each of the point charges in um, the line charges, and then we'd see how they interacted with each other. So here's what the result of the code looks like. So you can see the two line charges on top of each other, which represent the U-tapes. And then you can see the yellow gravitational force going down and the white electric force going up. Then if you look at the console, you can see the results we got, and then you see the new adjusted charge we calculated to be 38.8 nanocoulombs. So now for the discussion. So results and assumptions. So like I said, the result is that the charge on the U-tape was 38.8 nanocoulombs. And then some assumptions that we made was that the charges on both the U-tapes are about equal and uniformly distributed along the tape. And then we also chose to ignore air resistance and treat the upper tape to be in equilibrium. So now to answer some questions. So what if you had modeled each of your tapes as a single point charge like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. So if I modeled the tape as a point, I'd get a smaller Q than with the line. This is because a point puts all of the charge in one spot, which makes the field stronger. So you need less charge to get the same effect. And then why do these estimates differ? Which value is more likely to be closer to the real value and why? So they differ because a real tape is an extended rod with charge spread out across its length, not a point. The line charge model matches the geometry and end effects better, so its Q is more likely to be closer to the real value because the geometry of a line charge is just much more similar to a piece of tape compared to a point to a piece of tape. So in conclusion, GlowScript was a very powerful tool that we used to assist in visualizing these complex topics that I discussed. And then also, the line charge calculation gave a more accurate representation of the pieces of tape than the point charge. However, the point charge was much more simpler to calculate. So, if you need a very accurate answer, the line charge is better. But if you're just looking for a rough estimate that you can get quickly, perhaps maybe a point charge will be better. Thank you.